Hello Internet, welcome back to the workshop. So a couple of weeks ago I was turning a collet down on my mini lathe and I think I burned up the motor. I noticed it was smelling warm and it got to the point where when I would shut the lathe off it wouldn't start going again. And I discovered if I spin the spindle just a little bit it would pick up speed and it would work. So I pulled the motor off, took it apart, everything looked good except for the brush on the white wire, and that one was pretty badly worn. So I reshaped the brushes with some sandpaper, got them cleaned up, make sure they slid well. Tested it on the bench, everything seemed good. But when I put it back on the lathe and it was under load, the same thing happened. It started making that grinding noise and it started arcing. So here's a quick video I shot showing kind of what that sounded like. I'll turn this on so you can see it running, but keep an eye on the back side of that motor. So I figure this motor is toast. It's a 90 volt motor. I don't know the speed. I'm guessing somewhere around 2500 RPM. So I found this Treadmill motor on eBay. This one is a half horsepower, 90 volt DC that spins at 2450 RPM. I thought it would be a good replacement for this one. The downside with the new motor is it's quite a bit bigger and it's got an external fan. I didn't realize that when I got it. I should have looked a little more closely. But in today's video, we're going to make a bracket to bolt this motor to the lathe. We're going to figure out what pulleys and belt I need, wire it up, and see if we can get this going again. If that interests you, stay tuned. We'll get started. The original motor on this lathe mounted with these two studs through the lathe bed, and it tucked in right down here. It fit quite nicely. Because the new motor is bigger, it's not going to fit down there. And because it's got this external fan, I'm wary about mounting it too close to the chuck, just because I don't want chips and everything else thrown into it. So I'm thinking we're going to have to mount it out a ways. And looking at this, I'd like to have room under it to put a control box for wiring. It needs to be mounted far enough away that I still have access to the 2-speed gear lever. So I'm thinking maybe somewhere about, right here. I've got those holes down there that the original motor hooked to, and I'd like to use those. I'm going to make something that looks like just an L bracket that will mount through the original holes to the lathe bed, and then the Treadmill motor will sit on top of it with slotted holes. To better illustrate what I'm thinking, because it's kind of hard to see over there. So we've got the plate that will come straight out that the Treadmill will mount on, and I'll slot those holes so that I can move the motor in and out for belt tension. It'll come down on this side, and this is the face that will mount to the lathe bed. I'll add a reinforcement or a reinforcing rib to the side with another hole here so I can mount it to a new hole on the lathe bed. And on the back there will be a couple of holes that will mount to the existing motor holes on the lathe bed. So it's going to be something like this. I'm going to make it out of 3/16 inch steel. I took some measurements, and this needs to be about 6 inches long. This height 3 inches, and then this rib would just be whatever scrap I've got. I'll find something that's close. So let's go outside. I'm going to cut all these pieces out of 3/16 inch steel, and then we'll make a jig and weld it together. So this is the bracket all welded together. It's going to now sit in here like so. I need to figure out where these holes for the motor need to mount, because they're going to go on there somewhere about like so. But I need to figure out where they're going to go and drill those holes. And then I also need to drill the holes where the back plate will mount to the original motor mounts. So I'm going to mark those with a pen, and then I'm going to drill a couple of holes up top that I can slot. And then I'll locate the bottom ones in the middle of that motor adjustment travel, just to give me some adjustment in this direction and some adjustment in this direction. So this looks alright. There's even room here for the wire to pass through, which is good. Something I didn't think about. Let's put the treadmill motor on and figure out where that needs to go. So I'm thinking the treadmill motor will sit kind of like this. There's these two holes in its mount. I'm going to drill those out, and that's where our bolts are going to go that hold this on. So I'm going to mark this and we'll drill those holes. Here's a better look at that bracket that motor was mounted to. I'm going to drill through these, and I'm going to use these as my mounting holes for attaching it to the bracket I made. So I slotted those holes, and because it's slotted, it will allow me to move this motor for alignment as well as tension the belt. So I've got the motor mounted, everything's bolted in place on the new bracket. I'm really happy with where it's at in the position, and I want to focus my energy now on building the guard. I'm thinking about probably a 3-piece guard. One that covers the motor and protects the back of the fan. One that fits on the inside here to act as a belt guard. And then another one that fits over the top to act as a second or a pulley guard. So the first thing I'm going to make, I want to make the one that covers the motor. So this is how I hope that motor shroud will come out. So I'm going to take a piece of 16 gauge steel. I'll take a flat piece and I'll bend a 90-degree on it. And then I'll wrap that around a piece of pipe to give me this round shape. And this is the shape that'll fit around the motor. And then on the bottom side, I'll do the same bend. So it'll have that same 90-degree bend. And this top, so this is the top here. And this will attach to that treadmill bracket with a couple of screws. And I'll do the same thing down below. Maybe I do. So I made it about this far in 2 hours. I forgot how hard it is to actually bend 16 gauge steel by hand. This motor, the brushes stick up, and I'm having trouble figuring out how to get around those. I might cut this and try to get around the brushes and then make some sort of extra cover for those. So let's try that. Back outside. If I look at these brushes, I've got probably a 1/4 inch clearance in there. All in all, I'm pretty happy with that. So this is the main motor shroud, and I'm thinking then I'll add a second shroud that covers the belt. So this will be the inner shroud, and it'll sit kind of like so. I left extra here because I'm going to bend that over to create a nice edge. There will be another piece that sits on top of this that acts as the outside shroud, and it'll be about the same shape, but it will include an edge that clamps against this. So I'm going to go outside, I'm going to use the reciprocating saw, and we're going to cut this piece out. And the way I'm going to secure this to the motor shroud is I'm going to make some L brackets, and they're just going to get welded, probably plug welded to the shroud, and then I can put screws through here and into these L brackets. I'm going to use a couple of sheet metal screws. I want to make sure the brackets go in the right place, and so this will hold them there long enough for me to get them welded. So let's get outside. I'm going to cut this, I'm going to weld it on, and you'll see me make the rest of the belt guard. So I welded the inner cover together. So this is now one assembly. It joins to the motor shield with these 3 bolts. Then my outer cover will go on. And then the way I'm going to hold this on is I'm going to capture some nuts, probably 6 of them. So like 1, 2, 3, 4, 5, 6. I'll drill the holes here, put them in place, and then I'll weld them. And then once that's done, I can take the bolts out and I'll have a good solid way to hold this cover in place. So now I need to figure out where to pop the holes in this so that I can get this bolted in place. And then once I have it bolted in place, we can relocate that lever. I marked the location of those holes with a punch, and then I drilled them out and I screwed in some M6 socket cap screws. So I'm going to take it apart now, and what I want to do is weld these tabs on. So I can get those welded on, I can capture a nut on those, and then I'll drill the holes on the inside, and we'll secure this to the motor mount with similar cap screws from the inside. The gear I ordered for the spindle side drive came in the mail. So today I'm going to make this look like this so it works on the lathe. I need to get rid of these 2 steel guards because they're too wide. I need to cut off this excess material to get it down to the same thickness, and I need to cut a key so it matches that gear. This is a 20 tooth, so that's going to give me a 1-to-1 on the drive. So 2400 RPM on the motor, 2400 RPM on the intermediate shaft, which will give me 1200 RPM on the spindle in low and 2400 RPM on the spindle in high. So let's mount this in the mill here and get it cut down. I'm going to mount this in my 4-jaw on my rotary table. I can't take off a lot with this. If the cutter binds in any way, shape, or form, it bends the spindle. So I've learned to take really light passes. It's not rigid enough to do more than that. So that's how that turned out. Not too bad. I roll it around. So with that pulley there as cut, it sticks out about, I'd say maybe 1 millimeter or 1.5 millimeters too far, and would rub on this cover. So I want to make sure that this face contacts this outer edge of the shaft here. When I mill this down, I want to make sure I leave enough that it acts as a spacer and keeps it where I need it. I'm going to take these side guards off, and I'm going to take 2 millimeters further off of this face, and then we'll bring it back. We'll try it again. So here's how that came out. I don't know if you can see that. So with that cover on, I've got about 2 millimeters of clearance between that gear and the cover. I think that looks pretty good. It's not in enough that I could get a snap ring on here, so I want to take and just cut it in a little bit further, but only on the inside. I don't want to take any more thickness off the outside, and that's just so I can get a snap ring in and on this shaft. I think that looks really good. From the side here, it's right up against the inside edge of the snap ring groove. I think I'll put a snap ring on here, just make sure it fits. And if that looks good, then we'll cut the keyway. Yeah, so we're like the tiniest little bit off. It's close. If I were to push it, it would go in, but then I would never get it back out. So now I need to figure out where the key is, or the keyway goes, and we'll cut that in. And what I'll do is I'll just put it back in the mill, make sure it's centered again, and then I'll have to use the file to square it up. That turned out alright. Now let's file these edges. Alright, let's see if this fits. I mean, it looks alright. It's been a little bit tight. I'm going to push the key down. Yeah, that fits pretty good. I mean, it's a little bit tight, but I think it's alright. Before we can really get the belt on, I got to cut some clearance in the aluminum housing for the belt to pass through. I marked it in blue, that way I kind of know what I need to remove. I'm going to cut it out on the mill and then we'll take it back, see if it fits. I got a little carried away when I cut the inside. Kind of wish I had been just a little bit more shallow, but all in all, I'm pretty happy with it. I took all the parts outside. I just kind of cleaned them up with a flap disc. Make the edges a little smoother, fit some of the contours together better. I'm pretty happy with how it's looking. But what I'm working on right now is the lead screw direction lever. So I cut a notch here and the lever rides on this boss and moves back and forth. And what I did is I cut off the, I don't know what we call this, position plunger maybe. This is what would hold it in place so it didn't move. But I cut that off and now it can move freely. And I cut off a piece of an old U-bolt from the Dodge pickup. And I'm going to weld this onto that mechanism. It'll act as a lever that lets me move that. And then I'm going to weld that position plunger onto the end. So what I'm going to do, I'm going to take this and I'm just going to weld this on. And then we'll bring it back, make sure the lever works, and then once I know where that is, I can weld this onto the end of the lever and then drill the divots. Here's how that lever fits and works. That will move up and down, and you can see that will move the position of those direction gears. And then I'm going to take the plunger that I removed, I'm going to contour this, and I'm going to weld this plunger onto the end of this, kind of like so. So I'm going to clean this up. Let's get it welded on here. Alright, so that's kind of how that's going to work. And then to change gears, I'll pull this out, rotate the lever where I need it, and when it's in the proper position, the plunger will fit back in a hole. So I need to put the gears on now, figure out where those proper positioning holes will be, and drill them. So this is where I'm going to drill the divots. This location is neutral. I've got equal distance between the gears and the drive gear. So this is neutral position. And then if I go all the way up, this is, I don't remember which way this is. This is left or right. And then in the all way down position, right there, the bottom gear engages. So all the way at the ends of travel, I have to be a little bit careful because it can push too much pressure between the gears and not leave enough interference for smooth operation. But I'm going to mark these with a punch and go drill them out. I ended up just drilling it all the way through with a 3/32 inch drill bit. And that gives me really good engagement. The plunger sits down there really nicely and tightly. And like if I slide it, it really positively engages. So I think that's really awesome. I'm proud of this. I think the next thing to do is to build the fan guard. And what I want to do there, I want to put the chip guard back in place, and then I want to have this motor or this fan cover come up and touch this. What I'm trying to do is keep chips from getting down in this opening and getting caught in the fan or pulled into the motor and stuck to the magnet. I pulled the shroud off, I've got it bolted together, and I made a piece for the fan guard. I added this bend, and it's going to be similar to the bend on this, where it's just there to add some rigidity. So this is going to go pretty much just like so. And I've ground it as smooth as I can get it, because what I want to do is weld it just like I did on the other side and get a contour that doesn't catch my hand. I just cleaned it up a little bit with a flap disc to make it not sharp. So I don't have the change gears in, so the lead screw is not being driven. But I have most of the parts I made put on, and things are looking alright. I've got it in, what do I have it in? Forward, and the spindle is in low. And I'll show you what it looks like. But stand back. It works alright. When I shift it into high, it gets a little scary. a little scary. I need to notch the belt guard for the lever. Here it's hitting that, fouling on that. And I want to take and just clean up these welds so they're actually smooth. And make those look a little bit better. And then I'm going to paint this. So let that paint dry overnight. I actually really screwed up the second coat. I picked up the wrong brush, and the one I picked up had oil in it. So we made a real mess of the second coat. It's all clean, everything's together, and it seems to work pretty well. I want to show you. I've got you guys set up so you get the operator's view. So from your point of view, we've got our speed selector, low, neutral, and high. And you can see I notched out this guard so that the lever would work and have appropriate clearance. On the side here, I don't know if you can see this, but we've got that 2-speed lever. So lever's there, we've got our speed up here, and of course to use this thing, forward and select a speed. And if you want to run it in reverse, so that looks pretty good. I'm really happy with it so far. Now I haven't run anything on it, so we'll see how it performs when I do that, but everything's together. I like where everything turned out. I'm actually happier with the positions of the lever and the lead screw direction than I was when the lathe was original. So now that we've got the treadmill motor together, I want to try it out. I need some bolts to hold the apron to the carriage on my Atlas lathe. Should be a really straightforward project. I'm going to chuck it up in the lathe, we're going to turn off the hex, and then I'm going to use the grinder and we're going to grind a slot into it. So I'll bring you around here so you can see what I'm doing. I've got an ER20 collet in the chuck on the lathe here. This one is actually for my mag drill, but I figure if I chuck it in here, then I can run an ER20 collet on the mini lathe. I'm going to use the carbide bit and we're going to take just the hex off this head. Forward, on, speed up. The surface finish is alright, but that's working pretty well. I'm going to go try this and see if it fits. Yeah, that fits beautifully. I'm going to make a second one. I need two, this way they'll match. And then I'm going to switch around and we'll face them to take the letters off. I actually like the second one better. So I'm going to put them back in here now. I'm going to face them to remove the lettering. Alright, so there they are. This one's a little smaller. I'm probably going to redo it. I got a little carried away, but I think these look alright. So I'll admit, I did not want to do this project. I was perfectly happy with the motor that this lathe came with. Had that motor not died, I'd still be using it as was. Now, fortunately for me, that motor did die, and I will say that this project was absolutely worthwhile. The new treadmill motor has significantly more power and torque. I can run the lathe slower and I can take deeper cuts. If you find yourself in the same boat, if you've got one of these and the motor dies, or if you've got one of these and you want more power, you want to increase its usability, putting one of these treadmill motors on is the way to go. You can use your existing DC controls, and as you saw me do, really all you have to come up with is a mount, a pulley setup, and some way then to shroud it or guard from chips and from your fingers. So if you enjoyed this, would you consider subscribing to my channel? I put out content like this on a pretty regular basis. I've got 2 videos coming out soon. I'm converting a Walker Turner drill press into a milling machine, and I have a collection of scrap parts on my workbench that I'm going to put together into an Atlas 12-inch lathe. Both of those videos should be a lot of fun. So if you subscribe, you'll know when content like that comes out. I want to thank you for taking the time to watch this. I hope you have a good day. Thank you.